Perfect. Yeah. So, are you getting it, guys? So, what happens is the Hive or the SQL is the processing part, which is the MapReduce part. We will understand that in detail. Even MapReduce can be done in multiple ways. The processing can be done in multiple ways. You can write a Java program. You can write a Python program. If you say, no, I don't know Java, no Python, then you can run a SQL program. So MapReduce can be done using multiple things, using Java, Python, R, and even SQL. Okay.
Okay, sir.
Okay. but MapReduce जो है that is bit slow. That's why it's getting replaced with Spark. We will talk about that when we will learn Spark after 2 weeks. But firstly, MapReduce is very important. Companies are using it, but some companies are moving away from MapReduce to Spark. So Spark is the competitor of MapReduce. It's just processing. It's just processing. Spark does not have any storage. Okay, so for processing, we have MapReduce, and something which is much faster than MapReduce is Spark. So now if you go for interview, someone will ask you what is the storage layer? It is HDFS. What are the processing layers? So MapReduce is the processing layer, yes, but there is a faster or a better option, which is Spark. Okay, so for processing, we have two options, MapReduce and Spark. But for storage, we have only one, which is HDFS. And then there are some new solutions, which I'll talk later. But these three are the whole content for your class. Understanding HDFS, MapReduce, and Spark. Okay, so let's move ahead. So guys, what I'm going to teach you is a Hadoop architecture, HDFS architecture, MapReduce architecture, Spark architecture. So all architectures we are going to learn. So let's go ahead. So let's start with this. When I say Hadoop architecture, that means how the cluster will look like. Okay, Rahul, how the cluster will look like. So the cluster will contain multiple machines, and the machines have a special role to play. So we will always have one master machine. There is one master which is connected to multiple slaves. Remember, one master machine and multiple slave machines. So if you say, Rahul, I need a 100 node cluster, so out of you need 100 nodes. Okay, that means you need 100 data nodes, 100 slave nodes, but you need one more, which is the master node. So you need 101. Okay, so always you need one master. I'll tell you why. But master is also known as name node, and slaves are known as data nodes. So in terms of Hadoop architecture, we say master node as the name node and the slave nodes as the data nodes. So there is a name node, and then there are multiple data nodes. So you have only one name node, but you have hundreds of data nodes or the slave nodes. So what really happens? Let's see. Now let's go a bit inside. Even this will be complicated. I want to start with a simple one. So let me start with this simple one. So see, in Hadoop cluster, there will be one name node, which is the master node. And then there are these yellow machines are data nodes. These are 5 data nodes. You have 5 data nodes here. Now, how the system works? How the system works? This is a client. Client means a person or a program which wants to store the file. Say, for example, you have a 10 GB file that you want to store in Hadoop. So what you will do? You will contact the name node and say, hey, name node, I want to store this 10 GB file. Can you please store this in Hadoop? It will say, okay, fine. Name node will go and check the data nodes and ask, hey, data nodes, which one of you is having space available? So say, for example, these three will say, no, we don't have space available. But these two say, oh, we have the space available. So name node will say to the client, okay, give me the file. I have the available space. So client will send it that 10 GB file. And what name node will do? Say name node will split this 10 GB file into small files. In this case, let's say only two data nodes have the storage space available. So we will give 5 GB data here and move 5 GB here. So this 10 GB file will be stored in two parts, 5 GB on this machine, 5 GB on this machine. Okay. But this, first of all, this is how it happens. Client will come to the name node, say, I want to store a file. It will check which data nodes have the storage available. It says, okay, these have storage available. It store that file, bigger file over there, but in the small chunks, in the small parts. Half data is here, half data is here. So name node is just the master. It does not store any data. It just store the data on the data nodes. So your files will be stored on data nodes only, not on the name nodes. Remember, name node is just a master which makes sure that the data nodes are working fine or not. We'll talk about it in detail. It will take like 5-6 hours to discuss about this architecture. We have just started with it. Okay. So this is the client which is coming to store the file. Okay. So the file got stored in these two machines, for example. Perfect. But now, say there was another client which now wants to read this file, this 10 GB file which was stored by client A. Now say client B or the person B wants to read that file. It wants to process that file. It wants to do some analytics on that file using SQL, Python, whatever. So this person will submit a, say, Python program to name node. And in that Python program, it will say, okay, pd.read CSV, for example, to create a data frame. So this client wants to read that file. So it will go to the name node and say, hey, I want to read that file. So name node will say, wait, let me check whether I have that file or not. So name node will check, oh, okay, yes, I have that file. And then it will go back to the client, say, yes, I have that file available. And do you want me to run the program? Yes, okay, fine. So what name node will do? Name node will send your program, say the Python program on this machine and on this machine. So your Python program will be running in parallel on two machines. Understand it. Your Python program is running in parallel here also and here also. Here it's processing the 5 GB data present here. Here it's processing the 5 GB data present here. Once both of these processing is complete, the data will be returned back to the client. So first of all, you see here that parallel processing is happening. So normally if your program was processing a 10 GB file on a single machine, say it would have taken, say, 1 hour. If you are processing a 10 GB file on a single machine, say you will say take 1 hour. But here you are not processing 10 GB, you are processing 5 GB here, 5 GB here. So your program will complete faster. It may complete in 30 minutes, half of the time. And this is only 2 machines. What if your data is stored on 10 machines? You will get 10 times parallel processing. 10 times of speed will increase. So if it was taking 60
Excuse
minutes,
me, sir.
one second. If it was taking 60 minutes earlier, it may take only 6 minutes in total. Okay. Yes. Go ahead. Tell me. Yeah, someone was having a question.
Sir, Sir, is it generally happens that the program or the file that we want to save breaks down into different part and then gets stored into these different slave nodes? Does this generally happens, or it is just kind of an example that you are providing us?
No, it happens. That's the most important part. These green boxes that you are seeing, no?
Yes, sir.
I'll explain you about that. Consider these green boxes are nothing but the parts of a bigger file.
Okay, sir.
Hadoop do parallel processing, distributed processing, and without distributing the data, you cannot do distributed processing. This is not an example. This is the actual thing which happens.
Okay, sir.
But there is too much details to it. We are just scratching the surface right now. We will go in the detail.
Okay, sir.
Okay. But yeah, very good. Please clear your doubts immediately. Okay. Now, what I am saying again, here you see this is a client which comes, which store the file, and that file gets split into small parts. So like I said that, okay, 5 GB here, 5 GB here. Then this another person comes, he cannot directly talk to data node. No one can directly talk to data nodes. They always needs to go through name node, and name node will allow them to run their programs on the data node. Remember, no one can directly connect to data nodes. That's why you have a master. A master is like a guardian. Okay, let's go into next level of detail. So you have seen that, okay, Rahul, this is name node, and Rahul, okay, these are data nodes, right? Now, do you remember racks? I told you that in a data center, the machines are organized in racks. I showed you also graphically, right? So this is what it is. That this may be one rack which contains 3 machines. This may be another rack which contains 2 machines. So there can be multiple racks. Okay. So this was about rack. Now, this client is there, which is say doing some read operation. This client is doing some write operation. That is fine. But now, let's see what is this metadata operation. Ops means operation, and what is this block operation? So understand it like this. Let's say there is another client who is coming to read the data. It's a read client. A client wants to read some data. So he will say, he will give the name of the file, right? Definitely. When client wants to read some data, it will go to the name node and it will tell, na, I want to read this file. Otherwise, name node kahega, bhai, matlab, what do you want to do? Tell me the name of the file. So ye kahega, okay, I want to read this file, F1. So this is known as metadata operation. Metadata means data about data. You just want to tell name node, I want to read this file. So that's a metadata operation. So name node, how will name node know that whether it has this file or not? That is also a logical question. That whenever someone come to the name node that give me this file, I want to read this file. So name node will not go to the data nodes and ask that, right? Say you have thousands of data nodes. So name node will not go to each data node and check that file. It will never happen. So what will happen is name node have some data stored with it. What is that data? Actually, that's not data, rather that's metadata. So name node always have metadata with it. So this, if you see, so this, you can consider that name node have some tables or file which contains metadata. What is that metadata means? The name of the file and which machines contain that file. Let's say data node 1, data node 2. Understand this. So name node, it does not have data. It just have metadata, means name of the file.
Like index.
Yes, very good. Like index, but it's something more than index. But yes, you can correlate it to index. So it will first of all have whether I have a file or not. So for example, another client comes and say, give me file F2. So name node will check its metadata and see there is no F2 file. So it will say, I don't have that file, go away. But this client comes, I need file F1. It says, yes, I have that file F1. but then it also needs to know that which data nodes contain those files, right? If F1 say was split it into 10 parts, then 10 data nodes will have that file, right? So you will have the name of those 10 data nodes here. So you will not go to thousands of the data nodes to read that file. You will directly go to only those 10 data nodes which contain that file. You will not go to other thousands of nodes to unnecessarily waste the time, right? That's the power of Hadoop. So name node, make sure that whether you have a file or not, like it knows, okay, whether I have a file or not, and which machines have that file. That's the most important part. So I'll talk about this block operation in a while, but any questions so far?
No, sir.
Okay. So remember, whenever a client wants to do any interaction with Hadoop, it talks to name node, and that is known as a metadata operation. Name node has a metadata stored with it. Okay. So that's about it. But now let's go back to this client, the one who is coming to write a file. This person, he wants to write a new file in the cluster. Say Titanic file, the Titanic file that you have, right? We do machine learning on that normally. So this client will go to the name node and say, hey, I want to store a file which is a 1 terabyte in total. So name node will say, oh wait, this is a very huge file. Let me check, do I have a space available? So it will check its metadata. It already have that information in the metadata, how much space is available, which machine is having how much space. It don't go to the data nodes and talk, right? It already have that information that which data node currently have how much space available. So it will check, okay, these data nodes are available. So, okay, give me the file. So you give it the file and name node will say, okay, now you relax. I'm storing your file. Once the file is stored in the cluster, I'll come back to you. You wait. So this guy is waiting. So what name node will do? Name node will check, okay, these data nodes have the space. It will go to those data nodes. Let's say this is 1 terabyte file. It will divide this 1 terabyte files into small parts. Those small parts, guys, are known as blocks. A bigger file is split into blocks. The smallest unit of storage in Hadoop is known as blocks. Okay. It split this files into small blocks. Let's say it creates 4 blocks. Let's say 4 blocks of the size each 1/4 TB, right? Which is around 250 GB, right? Let's say 250 GB block. So this file is split it into 4 blocks, each block of 250 GB. Okay. I'll come to the exact size of the block in a while, but let's consider that a file splits into blocks, 4 blocks. So what will name node do? Name node, you will see blocks here. So let's say you have 4 blocks, B1, B2, B3, B4. So it will store B1 here, but it will not store all the blocks on the same machine. Otherwise, there is no distributed storage, right? You need distributed storage. Data should be distributed in the cluster. So 1 block here, 1 block here, B2 here. So these green blocks that you see, these are blocks. So say this is B1, this is B2, and let's say these nodes also have space available. So this is B3, and let's say this is B4. So this is how the system works. A bigger file is split into blocks, and blocks are scattered across the cluster, distributed across the cluster. Now, there can be a question that, Rahul, why don't I store everything on one machine? So, see, if I store these 4 blocks on 4 machines, now tomorrow if I want to process them, I can do the parallel processing. I can run the program parallelly on 4 machines, and each same program running on 4 machines, but processing only 1/4 of the data. So your performance will increase, right? That is known as distributed processing. So one is distributed storage, another is distributed processing. Are you with me so far?
Yes, sir.
So to achieve, yes, Pankaj, splitting of data is done by the name node, correct?
So
Hadoop?
can you explain this distributed processing, like how it is working?
Yes. I'm telling you, we will take 2 weeks to understand this. When we will do manual programs, even then we will see this.
Like,
But
so
yeah.
what I feel like if the data is in the same block, so or like in the same machine, it will process more fastly. Like there will be no such type kind of thing like searching the whole, collaborating the whole data and then working on it.
Very good. Who is this?
Pankaj, sir.
Very good. Keep that question, 1 second. Splitting of data is done by name node, yes. And Ketaki, you are saying Hadoop works like a switch. I didn't get it. Hadoop don't works like a switch actually, but can you elaborate? Okay, you can ask me later as well, but yeah, Hadoop does not work like a switch. I think you are saying switches and routers, right? It uses switches and routers. It does not work like switches and routers because switches and routers does not have any storage. They just direct the traffic. Here you have storage. Switches and routers does not have processes. They cannot run a Python or a Java program. It runs the Java and Python program, right, Ketaki? So Hadoop uses switches and routers, but it is something more than switches and routers. Okay. Sir, is it possible like one node is working on SQL and another node is working on Python at a time? No, Madhu, no. Your question is partially correct, partially wrong. See, if you submit one program, Python program, then definitely Python will run for that program. It will not happen that that same program will run SQL and Python. I hope that's not the question, right? But yes, it may happen that some machines have only SQL, some machines have only Python. Yes. Means out of all these machines, some machines may not have a Python stored on them. So whenever name node need to run a Python program, it already know that I should not run the program on this machine because this have only Java, no Python installed on it. That can happen, but we avoid these things. We want to make sure that all the machines have same software. Okay, but yes, it can be done as a Hadoop admin when I created my own clusters. So we used to do this. Some machines only support SQL, some machines only support Python. That can be done, but it's not a good practice. Okay. Okay, Madhu. Perfect. Okay. So someone was asking something. Sorry, Pankaj. Yeah, can you repeat? I forgot.
So like I was just like if the data is stored in same block or in same machine, the processing, taking upon the data and working upon the processing will be much easier for this name for the this.
Very good. Yeah, very good. I remember question now. Yes. So see, you are saying that let's have only one machine, store everything on that machine, and you are not wrong because we have been thought about single machines so far. MySQL was stored on a single machine, Oracle single machine, Anaconda single machine, right? But in real world, that is not a good practice. Why? First of all, let's say the entire data is stored on one machine, and that data is again 10 terabytes of data. Processing 10 terabytes of data on a single machine will be very slow, first of all. But if you have that data across different machines, you can leverage the RAMs, CPU of each machine. You are not relying on the RAM or the CPU of one single machine. That's the first thing. You have multiple machines. Each machine is running the program on their own RAM and CPU. So performance will be faster. Plus each machine is only processing a part of the data, not the whole data. But then you asked a very good question that here the output will be aggregated. If I'm running a program in a distributed mode on say 10 machines, the output needs to be aggregated. Yes, that's one of the, I would say, place where the performance gets a hit. But again, I will tell you why it's good. You are saying that if I run program on all of these machines, ultimately the output that will come needs to be combined, right? Very good. Yes,
Yes.
output needs to be combined. So that's what is map reduce. The processes that are running on each machine is known as map. It's like divide and rule. You divide the work on the smaller machines, but then you have to combine them, right? So mappers will run on the machines, and the reducer is something which combines. So mappers runs, then reducer runs, which combine the data. And definitely that is a must, right? You cannot send the data to this person from each of this machine. You need to combine that, and then only you need to do any further processing and send it, right? But that thing itself is faster. The combining process is itself faster when you talk about running everything on a single machine. I am telling you that the distributed processing that you are doing is way much faster. It gives you so much time performance gain that this reducing process, which is definitely slightly on a more performance oriented, it needs more network shuffles, but still the overall benefit that you are going to get is 10 times better than running that program on a single machine. But yes, I'm not saying you're wrong. You are absolutely correct that that will happen. But the Hadoop is so smart that it has made this thing also very fast, which we will talk about. Definitely the mappers will run, then reducer will, let's say, aggregate the data and send it to the consumer, the client. But even that whole distributed framework is so faster, it will give you a lot of performance gain. Okay.
Excuse me, sir.
1 minute, 1 minute. Please hold your questions for 1 minute. Let me answer Pankaj's question. Then there are few more benefits, Pankaj, to this. This replication word, I was going to come after some time, but let's see. Say you are running entire program on a single machine. You are saying, Rahul, I will use only single machine to do everything. What if due to some network failure happen, some disaster happen, and this machine goes down? Consider that. If you are relying on a single machine and this machine goes down, you cannot do anything because whole data is lost. Whole data is lost. But if your data was distributed across the cluster, and even if one machine goes down, only the data which was present on that machine was lost, but not the entire data. That's the first thing. But I am saying there is a zero data loss. Hadoop has a zero data loss policy. Why? Because every block which is stored on this machine is replicated. It is having a copy on two more machines, let's say here or here. So there is some redundancy that is introduced. Means for every block, we have two more blocks which are on some other machines. So even if this machine goes down, your data is not lost because two more copies are there. Okay. And if the program which was running on this machine, because this machine goes down, the program also will be stopped, right? Hadoop don't do that. If this machine goes down and some programs were running here, those programs will come to the name node. Hey, name node, we were running on this node, it goes down. Name node will say, don't worry, let me check. You were running on the block, this block. Okay, this block is having copies on these two more machines. So let's do one thing, you go and run on this now.
So
and even if this goes down, it has one more copy.
So the program will run on these replicated blocks also, like if the data distributed.
Only in the case when the primary copy is not available,
Okay.
the program goes to the secondary copies.
Okay, good.
but it will not simultaneously run on the 3 copies.
Okay.
But again, this is very surface level things we are talking. We'll go into very detail. But yes, Pankaj, am I able to clarify your doubt?
Yes, sir.
Okay, so you're getting why distributed computing is so good. It's not only about a single machine. It's about, first of all, running program on parallel machines to gain the performance, to leverage the CPUs and the RAMs, to process only the minimum data, which is the block. Also, you have fault tolerance. Okay, and let's say another thing. There are a lot of things to answer your question. One more thing. Let's say you have 1 terabyte of data stored here. Tomorrow you need to store more data, but say space is not available on this machine. So you need to do vertical scaling. There is something known as vertical scaling and horizontal scaling. Vertical scaling means I have only 1 machine and I keep upgrading it, which is costly. Doing vertical scaling is costly. Horizontal scaling is add 1 more machine to the cluster. If you need more storage, add more machines. So that is more cost efficient and gives you further benefits. Okay. So yeah, but yeah, Pankaj, I'll keep answering that question in detail further when we go down. But yeah, hopefully that clarifies. Yeah, someone was asking something else. Please go ahead.
Yes, sir.
Yeah.
Sir, all this we are talking about is one client. What if there are 2 clients or more than 1 clients?
Okay. Okay.
So one client is asking for a Python program on the data nodes. Other client is asking for SQL program.
Very good. Very good. So I have first of all shared this link. This is the Apache Hadoop's link, their own website. You can read from there. Yeah. So let's first of all understand. Yeah. So what I was telling you is ki you know what is name node, what is data node, right? What are metadata, metadata operations. Then actual reads and writes happens at the block level. So it's block operations. You have blocks. The file is stored in terms of blocks. Each block is replicated 2 more times, like main copy and 2 more copy. Then there is the concept of racks. And we talked about distributed storage and distributed processing. So distributed storage is SDFS, distributed processing is MapReduce. But now again, good question. Let's say there is this client which wants to read some file. Read means, let's say the client is a Python program. This is a Python program. And then there is another client which is submitting a SQL program, right? So another client which is submitting SQL program. But both of these, they want to read the same file. Both of these, this Python program and this SQL program. These are 2 clients. Like one person is submitting a Python program for say Titanic file, and another person is submitting a SQL program for it. Definitely that can happen. So let's say who comes first. It's the question of who comes first. Python program comes first. Hey, name node, I want to run the program. Name node will say, okay, this file is stored in terms of say 2 blocks, 1 block here and let's say 1 block here. So Python program will come and it starts to run on this block and on this block. It's like distributed processing is happening because data is stored on 2 blocks. Your file was stored in 2 blocks. Perfect. Processing is happening. This SQL program comes to the name node. Hey, I want to run SQL program on this same file. Name node will say, okay, let's see. Okay, this file is stored in 2 blocks. One is this, one is this, but it's already being processed by someone. Someone is already working on this. I cannot allow you. I cannot allow you to work on the same blocks at the same time. But wait, I have the replica for this block. For this block, let's say this is the replica. And for this block, let's say here is the replica. So this SQL program will not run on the main copies. because the first program that comes will run on the main copies. This program will run on the secondary copies here and here. So it's not that this will wait. It will not wait for this Python program to complete. It will be also processing, but it is running on the replica. Are you getting it?
Yes, sir.
Okay. And there is one more thing which is known as there is sort of a queue which is maintained. Queue. Like first program enters into the queue. Then second program enters into the queue. So we have a queue. Name node maintains a queue of clients. For example, I was running that Python program. You come and you say, I also want to run this SQL program. So currently I am in the queue, right? So firstly, I will be given the preference. And then if the resources are available, then you will be given the preference. Otherwise, you have to wait for this program to complete. Understand it this. What I am saying is, definitely Python is also running, SQL is running. Now, two programs are already running in the system. Like Rahul's program is also running, Ketaki's SQL program is also running. Then Pankaj comes and Pankaj say, okay, I also want to do some processing. But I have limited data nodes, limited RAM, limited CPU, right? I cannot allow all these three people to run their program in parallel. So it may happen that some people need to wait. Those who are coming late in the queue, definitely they have to wait. But say Rahul's program is completed, Ketiki's program is still running. But since Rahul's program is completed, Rahul will release all the resources like CPU and RAM. So Pankaj's program, which was waiting to run, it will start to run now because Rahul has released all the resources once his programs are complete. So we maintain a queue. So it's not that if 100 people will come, I will allow all the 100 people to run their programs. No. They have to wait in the queue because the system has limited resources, limited network bandwidth. But still, it is far better. We can run hundreds of programs in parallel. In real world, we can run hundreds of programs in parallel. It depends upon your cluster size, the size of each data nodes, even how efficient is your name node. Name node also needs to be very efficient.
Excuse me, sir.
Yes, go ahead.
Sir, so one program can run on one block at a time.
No. Do you want to refine the question? One
Sir,
program, let me tell you, one program can run on 10 blocks also, provided those 10 blocks are of the same file. Means original file was divided into 10 blocks like this. This is block B1, this is block B2, this is block B3. Are you getting? If I want to read one file, but program always runs at the file level. Okay, program always needs to read a file. So name node will say, hey, the file you want to read, actually it was split into 10 blocks. So the program will run on 10 blocks at the same time. That's what the distributed computing is.
Sir, I'm asking that two programs can't run on one block, right?
Okay. So you are saying that if this is one block, means one small part of a file. A block is one small part of a file, right? And this Python program was reading this block. Can't this SQL program read the same block? Why you want to go to the replicated block, right?
Yes, sir, simultaneously.
Very good. So definitely that can also be done. Okay, who is this Ketaki?
Sir, Honey.
Honey. So what I am saying, yes, definitely that is possible, but that depends upon the kind of operation that this first person is doing. Understand it. This is the detailed level thing. If this person if this Python program was doing a read-only operation on this block, it was not editing this block, it was not modifying this block, then this person can also come. But if Python program is such that it is also editing or modifying a block, maybe deleting that block, updating that block, that at that time you cannot allow someone else to access the same block. So ultimately the concept is multiple people can do the read operation on the same block, provided they are all just reading it, they are not modifying it.
So same time of operation can be run on a block.
Yes. Means
Okay, sir.
Means even 10 different programs can read the same block if all of them are just coming to read the data. But if anyone is coming to write, then he will not allow others to do anything on that block.
Okay, sir.
This thing is known as locking mechanism. If you have heard about locking in databases, tables, there are some locks. So I'll talk about that sometimes later, but yeah. Sometimes what happens when this program come, it may come and take a lock, it lock this block. When you take a lock, no one else can come and work on that block. So we have some locking mechanism.
Okay, sir.
Sir, I have a question like if
One second. I am just giving you a very simple example. This is not Hadoop. Huh? This is not about Hadoop. I am telling you about MySQL. Huh? Don't relate it to Hadoop. Hadoop works in a different way. But I am telling you locking concept. In MySQL databases, you guys must have created tables, right? So what happens is this session 1 consider the user 1, and let's say this session 2 is the user 2. So user 1, when he wants to read data from this table, he can perform some lock operations. You can manually type a lock command. There is a lock table command also, lock table name, or there are some operations which by default take locks, like updates and inserts. So if this person has taken a lock on this table, and when this another person is coming to even read the data, he may or may not be able to read the data. It depends upon the type of lock. So even locks are of different types. One is known as shared lock, share, when you want to share. So if it's a shared lock, other people can at least read. But if it's an explicit lock, even you will not allow others to read as well. So I am saying there are different kinds of locking mechanisms, but this is not what Hadoop do. Huh? Hadoop is completely different, but because we were talking about it, so I wanted to give you an idea that the tables can be locked, and once you lock, the operations will be blocked. Okay. Please go ahead. Someone was asking something.
Yes, sir. These blocks are dedicated data is like, or in a particular block can have data from both like SQL and Python also. Like it is, or it is just dedicated to one thing, like data for Python only.
No. There is nothing like data for Python, data for SQL, right?
Okay.
Let's say, but yeah, that's also a good point. Let's say there is a Python program, and let's say there is a SQL program. This Python program reads this block. Let's say it reads this block, do some operation, and then it creates a new block from this block. You don't modify this block. Let's not modify this block. Let's say you read this file. Let's consider a very simple example. You have a file which contains only one block. It's a very small file which contains only one block. Okay. So you read a file means the block, you do some operation and then you finally created a new output block. This was your input block, and let's say you created an output block from it. Okay. So block has nothing to do with Python. It is a data element. It got generated from Python, it's fine. But for HDFS, there is nothing like Python or SQL, right? Tomorrow, I can write a Java program that may read this block, do some operation, and then generate a new block, which is say this. Now, this block was generated by Python, this was by Java. How does that matter? It's a file. For example, you are generating a text file. Whether the text file is generated by Java or Python, does it matter? It's a file only, right? Are you getting my point, or am I not able to answer your question?
Yes, sir.
Output file is an output file, right? Whether it is generated by Java or Python or R, how does that matter? It's a CSV file, it's a CSV file. It's not that, okay, it was generated by Python, so only Python program can read this file. No, that never happened.
Like, so I thought like these blocks are the only data like for like data which has the name node has distributed.
Yeah, so blocks are nothing. अरे, what is a block यार? ठीक है, वो आप अभी पहली बार ही समझ रहे हो इसलिए कंफ्यूज हो रहे हो. मान consider this is a file, right?
Yes.
Which have say 4 rows. Okay, a file which contains 4 rows.
Yes.
And let's say this is split into 2 blocks.
Okay.
Block B1 and B2. So a block is nothing but a subset of a file, which can, whenever you will read this block, let's say you want to open this block, I will show you guys, it will contain these files, these two rows. When you come and open this another block, it will contain the another 2 records. A block is nothing but a small file, yeah. It's just a small file.
So this was the question, like it is the dedicated, like for in Python we used to import some data, so the data is there, and this particular block will represent a particular data part. And if and if in the same machine or in the same rack, if there is SQL also, so some part of SQL data will be also there, represented by a particular block.
Okay.
And if I want to, so like there's a client thing, like if the
so first of all don't talk about SQL, huh?
Okay, sir.
Just talk about, say there is a Python program, there is a Java program, there is a R program, because
Okay.
SQL, when you talk about SQL now, tables and database ka
Oh,
concept
sir.
aa jata hai.
Yes, sir.
So don't get confused. I think
Yes.
your question is not about SQL, it's about different languages only, right?
Yes, sir, it is about the data. Like if there is a different data, the name node is distributing different types of data that already been given by this client, and then and then some programming will be done like by Python or R. So that can be done in particular rack at a time, or it will be like you said just before, like there will be some sharing or there will be some waiting for processing.
See, first of all, if a Java program there is a Java program which stores some data, that data can be read by the Python program also or R program also. First of all, if Java generates some files, let's say a Java program generates a file which got split into multiple blocks, so those blocks will be split across the cluster, huh? But tomorrow a Python program can also come and read those blocks, a R program can also come and read those blocks. So once the data is stored in terms of blocks, it does not matter which program generated that data. Anyone can come and read that data. There is no access control that only Java generated this, so Java program can only read it. There is nothing like that. Anyone who have the access to Hadoop can access the data. And as soon as the data is stored, it is replicated. No one is coming and saying, I want to do replication. As soon as, say, a file is stored, the file first will get split it into blocks. The first thing that happens, let's say block B1 and say block B2. So B1 will be stored here, here and here, 3 copies. B2 will also be stored maybe here, 1 copy here and here. Anywhere, it can be stored anywhere. Huh? Pankaj, anything else?
Yes, I got it, sir. And if the data is if anything will be deleted, so this replicated file will also be
Yes. If you delete the file, let's say someone come to the name node and say delete the file. So it will search how many blocks were there. Okay, B1 and B2, there were 2 blocks. Then for each block, how many copies are there? Each block will have 3 copies, right? So total 6 blocks will be deleted. Total 6 blocks means 2 original blocks and 2 more copies for each. So each block total have 3 copies, right? So all the 6 copies will be deleted. So if you want to delete a file, it's not only the blocks, but their copies also gets deleted. Okay. And no one can any longer access it. So if someone comes and say name node, hey, delete this file, so everything is gone. Blocks, files, replicas, everything is gone. Okay.
सर अगर कोई डिलीट करने को ना बोले तो वो कब तक रहती है फाइल?
परमानेंट, लाइफ टाइम.
सर तो उससे स्पेस वेस्ट नहीं हो रहा?
बट दैट फाइल
करेगा ना क्लाइंट से.
अरे but that file is important, right? For example, you are working for, say for example, you are working for Google and Google finance team, and a file contains all the employees information. Would you like to delete the employees file?
सर सपोज किसी पुरानी कंपनी ने फाइल दी, अब कंपनी भी बंद हो गई, तो वो फाइल इंपॉर्टेंट नहीं है?
As a data scientist, don't you think that you need history data? So just on a funny side, but yeah, your question is good. But consider it's not about the file, it's about the importance of the file, right? How important that file is. If a file is not important, you have to come and delete it. It's not that Hadoop will delete it, because data is always important. We say data is the new oil, right? Data is the new currency, right? If you have more data, store it. And that's where Hadoop is important. Hadoop, it's cheap. Hadoop is very cheap to store the data. Hadoop is there to store petabytes and terabytes of data. Na? Hadoop is meant to store the big data. Here you don't have to worry about the cost of storing anything. Though cost is involved, but it is not huge.
So but space कभी तो खत्म ही होता होगा.
Very good, very good. Definitely that happens. But again, I'm saying now, then you have to decide the deletion policy, the purge policy, delete policy. So you have to come and delete.
If we don't delete, then it gets charged.
See, when you take a Hadoop cluster, by default you get say 1000 terabytes storage, for example. By default you get, say, I'm giving example, it may be less or more. You get a Hadoop cluster with 1000 terabytes space. It may take your company 10 years to even consume 1000 terabytes. Agree, disagree? It depends upon the size of your company.
Yes, sir.
It may take 10 years to even consume that initial 1000 terabytes also. So, but after 10 years, you realize, hey, my cluster is out of space, let's delete. No, that never happens. Even after 1 year, you start to analyze that the data, which data is important, which is not. So you have deletion policy, delete these files which are not important. But you have to decide, I'm saying. Hadoop will not decide this. Because Hadoop,
okay, sir.
Tomorrow you can take that Hadoop company to Supreme Court or somewhere, hey, why you deleted my data? That was very important. You can sue them, right? If some other company is managing your data center, you can sue them. Why you deleted my data? It was very important. So Hadoop says, hey, I'm giving you everything, but you have to decide what to delete and when.
Okay, sir.
Okay, any changes work on primary? But because you have asked it, let me tell you one more thing. Whenever you are storing the data in Hadoop now, any file, there is something known as retention period. While storing a file, you can set something known as retention period. Let's say while storing file F1, you say 1 month. While storing file F2, you say 1 year. So after 1 month, this file will be automatically deleted. So this is known as a good property given by Hadoop, retention period. While storing the files, you can set the retention period. You retain it only for this much time, and after that automatically delete it. I don't want to come and delete it. So while storing multiple files, you can store different retention period.
Sir, extend हो सकता है ये?
हाँ, definitely. For example, you set a retention period of 30 days. You can come on the 29th day and extend it for another 100 days or whatever.
Okay, sir. Okay, sir.
But yeah, very good question. Okay. Any
Excuse me, sir.
one second. What Pankaj is saying, any changes work on the primary block but not replicated on this. No, Pankaj, see, if someone modifies the primary block, the secondary blocks automatically get updated.
Okay, sir.
That's why I said, no? That's why I said that locking. If your program is only read, then multiple people can read. But if you want to write, it will take lock.
Okay.
And sir, अगर कोई secondary file modify कर रहा है तो? Then the primary file will remain same?
Okay. Good point. 1 second. See, first of all, how the things works are quite, again, deep level. When let me delete this here. Say this is the primary block and say this is the secondary block. Okay. And this person comes to his reading. Okay. And the another person comes and he starts to modify the secondary block. Okay. But the secondary block modification which is happening, it will not take effect unless this connection is complete. You definitely can come and start your operation to modify the data, but that modification is happening somewhere in memory. It will not be reflected in the disk unless other people who are reading the data, they have done their work. Otherwise, the conflicts will start to happen. No?
Sir, समझ नहीं आया.
So keep this for the later time. Because what I am saying is, ideally, as a rule of thumb, only multiple people can read a block if they are just doing a read operation. They can access a block only if they are doing a read operation. But if someone wants to write anything, he wants to take an explicit lock. So if he wants to come and do edit operation, he will lock it. And while he took a lock, we also need to make sure that those who are reading it, they needs to go away. They need to first complete their work, then only this person will start his work. Consider it like this for the time being. If someone is already reading something and someone comes to write, we will ask this boss, wait for some time, let this person complete his work. He will complete his work, go away. Now you can edit. Just consider it that. Otherwise, the data will become stale, right? Conflicts will happen. So there is a lot of nitty-gritties involved in this thing. You have to have a certain level of understanding before it. But read about it, you will get more knowledge. Just consider, ideally, we don't allow multiple people to access a block if it is getting edited. Only when people are coming to read, we will allow them to read. Okay. Still any question?
Sir, I just I just want
Yes,
to
sir.
visualize this.
One second. Yep. Lokesh, go ahead.
Sir, in block operations process, the distribution or the breaking down of a particular file into small files, is it necessary that the distributed file is done in equal proportions? Like you said that 1 terabyte file
Very
distributed
good.
into 250 GB each.
Very good. So there is a standard block size. Okay, I'll come to it. Give me 2 minutes. But yes, all the blocks will be of same size.
And sir, my next question is that Hani said, sir, first of all, I want to ask that the block is a particular part of a file, na? So
Yes.
if we want to access to a particular file, then the name node will retrieve the whole file
Correct.
instead of retrieving a particular block. So
Correct.
how can anyone access to a particular block in a particular rack or a node, whatever it is? And my second question is, if I am
wait. One by one.
okay, sir.
One by one. So let's consider your first question. You already have a second question and then third question. So first question is, you have a file, okay? So every file is stored into blocks. I split it into blocks. Let's say 3 blocks in this file. All blocks always are of the same size. Okay. I was going to come to it after some time, but yeah. So this is a block B1, B2 and B2 and B3. So the default block size is 64 MB. So far I was just building your concepts. Now this is the next level thing. So every file is split into blocks, and block is the smallest unit of storage in Hadoop, and the default block size is 64 MB. As a developer, you cannot change it. Only admin can change it, the size. So if admin has set up that block size will be 64 MB, so this file will be split into 64 MB blocks. But in the new versions of Hadoop, Hadoop 2.0, we are currently talking Hadoop 1.0, now Hadoop 2.0, the block size is increased to 128 MB. So the default block size is 128 MB. So let me give you all some exercise. Let's say this is 1024 MB file. So you have a file which is 1024 MB. Okay. You have a file which is 1024 MB. Now when name node needs to split it, it will split it into blocks. Each block of 128 MB size. Can anyone tell me how many blocks will be created?
8.
8. What will be the size of the 7th block?
128.
What will be the size of the 8th block?
128.
So you say total 8, right? 1 second. Your maths may be very good. 1 second. 1024. No, not 1024. 128 multiplied by 8. Perfect. So let me change it a bit. Let's say instead of 1024, yeah, you are correct. Absolutely correct. Now, so you all understood, right? So if 1024 file needs to be split into blocks, each block of 128 size, it's 8 blocks, right? Total 8 blocks. Now, what if this would have been say 1028 instead of 1024, it's 1028. How many blocks? Guys, I want answer from everyone to be
9.
9. Okay, very good. But what will be the size of the 9th block?
4.
4
MB or 128 MB?
4
Guys, I want all of you to ping me.
Sir, 128 MB.
128 it will be, but the data will contains 4.
No, I want you to tell me what will be the size.
128.
Explanation nahi chahiye.
128.
Guys, you need to think. Some people are saying 4. I want all of you to ping, please. Mayank says 4. Okay, good. 4 Shivali, Ritik. Okay, go ahead, go ahead. There is nothing right and wrong here. Huh? You are learning. It's a learning phase. Okay. So all of you who says 4 and 128, they are correct. All of are correct. But yeah, the right answer is 4. The right answer is 4 MB. Why? Because ninth block, the file contains only 4 MB data, right? But first the block will be created. It will be 128 MB only. But when it see, oh, data is only 4 MB, it will only consume 4 MB. Rest 124, remaining 124 MB will be returned back to Hadoop. That's the storage optimization. And this thing was not there in previous distributed systems. They used to consume and waste the space. But that's what I'm saying, the power of Hadoop. Hadoop manages all these things for you. So the answer is 4 MB. Hadoop will never waste the space. Whatever is the empty space, it will return it back. So total 9 blocks will be created, but 9th block will be only 4 MB in size. Remaining empty space will be returned back to Hadoop for other files, some other files. Okay, so Lokesh, first question is answered, that a file is always split into blocks. Each block will be of equal size, but the last block will be only of the size of the remaining data.
Okay, sir.
Okay, can you
Yes,
repeat
sir.
the second question, please?
Sir, I'm asking that if I want to retrieve a particular file.
Yes,
then the
yes,
name
I
node-
remember, I remember.
Yes.
So you're saying when you want to retrieve a file, so say for example, now consider that same case, file F1 having 9 blocks. Now when you want to read this file, definitely you will lock all the 9 blocks at the same time.
So, sir, how can anyone manipulate a particular block? As you said that
Yes,
we
yes,
are allowed to manipulate a particular block in a particular node.
yes, yes, correct, correct.
So, if I want, suppose I saved a file, taking your example,
Yes,
and
yes.
9
Let's
nodes
say
are there,
this,
nine blocks are there.
this. Consider 5 here. Let's say we
Yeah,
have
yeah.
only.
Yeah, let's say we have 5,
These are the 5.
and if I want to manipulate a particular row, then how can I know that this row is in which block?
Okay, very good. Let me think how to answer this. I have multiple answers for this. Okay, 1 minute. So to keep it simple, I have multiple explanations for this answer. Sorry, I said I have multiple answers. Answer is only one. Explanations are multiple. Okay, so consider you worked on the tables, right? You worked on tables.
Yes,
in
sir.
MySQL. Very good. So say this is a table. This is a MySQL table, which contains employee ID, employee name, and employee location. So if you have to change the location of an employee, say from Delhi to Mumbai, what is the query that you will write?
What I have to do, sir?
For this table, there are 3 columns. I am asking you to change the location of the employee from Delhi to Mumbai. What is the query?
Sir, update.
Yeah, update, say state is equal to Mumbai, where state is equal to Delhi.
Yes, sir.
But what will happen? It will update for every employee, right?
Yes, sir.
What if I want to do it for particular employee?
Then I have to mention the employee ID also.
Very good. So that's the answer to your question. If you want to update something at the entire file level,
Yes,
so your query will be like that. If you want to update something at the row level, your query will be like that, right?
Yes, sir.
So same is the case with Hadoop. Hadoop is a bit more intelligent in its processing. When you say, okay, update everything, so means for the entire file you want to do the update, then it will lock each and every block and update each and every block.
Yes, sir.
So I was just giving an example that it will take a block and lock it.
Okay.
But yes, it will lock all the blocks.
But sir, it will retrieve the whole file, na, and then it will check.
No. That's what is distributed programming. Let's say you are running a SQL program. So SQL program will be running parallelly here also, here also, here also, here also, and here also. So if you have 5 blocks, your SQL program will be running on 5 blocks independently. Means this
Yes, sir.
SQL program is independent of this SQL program. So this
Yes, sir.
SQL program will only modify this block. It will not
Hmm.
retrieve anywhere, na?
Hmm.
You see, you are submitting the SQL program to name node, but
Yes, sir.
internally you don't know what is happening because you only know the file.
Yes, sir.
But name node know that there are 5 blocks, so it will
Yes.
run SQL program on 5 nodes, and each of these SQL program is independent of each other. This SQL
Yes, sir.
program does not know anything about this. This SQL program does not know anything about this. So while this SQL program is running, it is running on its local data. This is running on its own local data. Every program is running on their own local data. You are not retrieving all the data anywhere first and then doing processing. You are not
Okay,
doing
okay.
that.
Answer one more
And
question.
wait. No.
Okay, okay.
पहले इसको clear करो ना.
Okay,
Wait.
okay, sir.
हाँ. And this concept is known as bringing process to data. Okay. Very important point which I am telling you. Earlier, before Hadoop, there was, see, there are two things. One is data and one is program, right? There are two things. One is data, one is program. So earlier we used to send data to the program, but now we send program to the data. That's the biggest benefit with Hadoop. Data is not moving. Data is where it is. Yeah. So what I am saying is, you are sending your program to the data. Your SQL program is running on the 5 different machines. But before Hadoop kind of things, what used to happen? Let's say this is a machine where my program needs to run. So data used to travel. This block will go, this block will go. All the data used to travel to the machine which is running the program. Earlier, this used to happen. Data used to travel to the program, which was very bad because you are wasting too much of network bandwidth. Consider that you have to move 1 terabyte of file. So 1 terabyte of data is traveling in internet to that machine where program needs to run. Earlier, data was moving to programs, but with the Hadoop kind of systems, see, the program moves to data. Programs moves to data. So there is no data movement. You are saving so much network bandwidth. Internet पे आपका data travel नहीं कर रहा. So are you getting my point? This is
Yes,
for
sir,
everyone.
yes, sir.
I'm not explaining only for one person. So if someone asks you, one of the biggest benefit with Hadoop is program move to data. Data does not go to the program. Okay, and Lokesh, very good question. And to add to it, let me tell you one extra thing in this. 1 second. Even Lokesh, it can happen that if a file contains 5 blocks, okay, Lokesh, that's an advanced level thing. If a file contains 5 blocks, it may happen that I'm only accessing 1 block instead of all the 4 blocks. It can happen depending upon some advanced concepts.
But sir, will the user will know that in which
No,
block he or she is accessing?
Never.
All this is happening in the backend.
Yes, and it happens when you sometimes try to read a file, you want to read only some data. For example, where country is equal to India.
Yes, sir.
Consider it. These are advanced level things, but I'm saying it may happen that this contains Germany data, this contains France, this contains India, this contains America, and this may contain, say, Sri Lanka. And your program is such that it only wants to read India data. Then Hadoop will only direct you to that block which contains India data. Why unnecessarily you read these files? These are advanced concepts known as partitioning and bucketing. We will learn it, but let me type in the window that with the concepts of partitioning and bucketing, we can even control that not all the blocks should be read, only specific blocks should be read. But these are advanced things. Yeah, Lokesh, tell me next question.
Sir, I want to ask that the word which we are using, machines,
Yes.
are we
yes.
referring them to a particular plate in a particular rack, or we are referring to a particular rack only?
No. Whenever I am saying machine, it's the most granular unit of computation. That means a unit which contains its own RAM, its own CPU. So a machine means this. This is a machine. This is another machine. The yellow boxes.
So basically a particular plate in a particular rack.
Yes. So you see, this is a rack.
Okay.
So in this rack, this is one plate, this is another plate. So that means this is one computer. This is another computer. So ideally, machines means it's a data node. Data nodes.
Oh, okay. And sir, are we allowed to distribute our files in different racks also, or our file will distribute it in a particular rack in different machines?
Okay. A very good question. Again, you guys are running ahead, but I really like this. You guys know what is disaster recovery? Disaster recovery is one of the concepts which says that in terms of any machine failure or system failure, my data should be available. I should be able to recover my data. Disaster recovery. So if this is a block, let's consider about this rack. If this is a block, its first primary copy is here, its another copy is here, and let's say within this rack there was one more machine. Third copy will never ever be on the same rack, never. If this is the first block copy of the block, second copy, third copy will never be on the same rack. It will always and always be on the another rack. Why? Because if this data node goes down, immediately I will access this data node because of this block. But consider the entire rack is down. That can also happen, right? Then my data still is available, but on some other rack. If I keep all three copies on the same rack, and in worst case, if the entire rack is down, my data is again lost. So Hadoop is again intelligent. I am telling you again and again, these things we used to do our own when we used to build our own distributed systems. As a programmer, as a developer, I had to take care of all these things. But Hadoop internally takes care of all these things. That's why it's very intelligent. This concept is known as rack awareness. Lokesh, getting my point?
Yes, sir.
Okay, 1 second. So this concept interview, this is being asked in interviews. Okay, what is rack awareness? See, rack awareness in Hadoop is the concept that chooses closer data nodes based on rack information. Means you read about it more, you will get more information. But what we are trying to tell you is, say this is a block. Consider this is a block. I'm just telling you this rack contains only two. See, this every rack only contains 2 copies. Third copy is always on the other rack. If these are the 2 copies here, these are blue blocks. The third copy is here. Again, 2 copies here, but the third copy is on some other rack. Are you guys getting my point?
Yes, sir.
So not all the 3 copies will be on the same rack, because racks are also connected with switches. Like the nodes are connected with switches, racks are also connected with switches. Okay. Like this diagram. So switches, racks are also connected via switches. And data nodes, these are your plates within a rack. These are your plates, but we should say them machines, or we should say them data nodes. Okay, so data nodes are also connected through rack switches, and racks are connected through the outer switches. So there are internal switches which connects data nodes, and then there are outer switches. Okay. So we'll take a break here, guys, for 15 minutes, and after that we will take more questions. Meanwhile, you Google, comprehend these things, and come up with more questions. Then we'll do some hands-on after this. Shivali is asking, so is partitioning of data also based on certain condition or randomly? So Shivali, you are talking about what partitioning? Because I also ping partition and bucketing. You're talking about that partition, or you're talking about the block creation?
The block creation.
So block creation, we'll talk about that after the break.
Okay, sir.
But that's also a very good question. Okay, so guys, let's connect at 12:05. We'll connect at 12:05.
Okay, sir.
Let me know if I'm audible.
Yes, sir.
Perfect, perfect.
Yes,
So yeah, so someone was asking about how the blocks gets created, right? So one second. I'm sharing the screen. Okay. Yeah, so it's very simple. If you have a file that needs to be split into blocks, it's always a sequential step, simple. There is no important logic. So if say this is row 1, 2, 3, 4, 5, 6, they go into one block, then 7, 8, 9, 10, they go into another block, and next they will go into another block. So it's always a sequential process, okay? There is no data, like no random data shuffling, waffling, no, nothing like that. Okay.
Sir,
So the blocks, they are created sequentially only. First few records in one, then next few, and then next few, like that. So it's a sequential splitting, not a random. Yeah, tell me.
sir, if we are using the update query in SQL, then it will do the changes in the file or in the block.
Correct.
Yes. So if another user comes in and that user wants to access the original file,
Okay, perfect.
then how can that be done?
Very good. Yeah, who is this? Mayank. So Mayank, first of all, see, logically speaking, if someone modifies something, right? So it's done, right? Modification is done. So you cannot access the original copy. So there is no way you can do that, right?
Yes.
So there is no way. If you
Okay.
have modified something, that's modified. That's it. There is no replica. There is no means backup or something. There is no backup for that. Even
Okay.
replicas will also get updated.
Yes.
Okay.
So there is no way to access the original file again.
No,
Okay, sir.
it's the same case in a database also, right? If you modify a table, you
Yes.
have to always access the latest data, right?
Yes. Yes.
Okay.
Okay, sir.
But
Now, what is
wait. But since you have asked this question, so let me tell you one more thing, that Hadoop is not meant for updates. Ideally, we should not update anything in Hadoop. Hadoop is meant for big data. So big data, we avoid updates. So what
Okay, sir.
happens is, if this is your original file and you have to make any changes, we always create a new file out of it,
Okay.
which is the updated file. We never modify the original data,
Okay, sir.
because you consider it like this, Mayank, that for example, you have 1 million rows, because we are talking about big data, right? So you
Yes.
have 1 million rows, and in that you want to update one particular row.
Yes.
So you will first read the entire file, come to that part and then update it.
Hmm.
Ideally, big data does not recommend that. So Hadoop and big data says that your files should never be updated. You can delete them. Okay, you can add more data, means you can add more rows to it. You can delete few rows or you can delete all the data, but you should not update them.
Okay, sir.
If you have to update, rather create a new file out of it which contains the updated values.
Okay, sir.
So in that case, you can access the new data and the old data.
Yes.
Okay. Yeah,
Yes.
someone else was there.
I already got the answer from your explanation.
Okay.
Sir, can I visualize like, how this splitting of data and this replication work? Like, if this block is formed and each block has some replication, so if any modification will be done, so that will be done on this all those replication and the main block, or only the main block, like the
Okay.
primary ones.
When you modify,
Yes.
you
Sir.
modify the main blocks.
Okay.
But system internally have a process of updating the replicas. So it may happen at a latency, maybe after 10 microsecond or 100 milliseconds. That is up to system, but system makes sure that if you modify the original block, other two blocks also gets updated.
Okay. Like you said,
Ideally,
yes,
wait.
sir.
Ideally, as I am saying, we should not update a file or a block. We can delete a block, we can delete, or we can add more records to it, but we should not update. However, if in some of the cases you do update, let's say, then system automatically update all the replicas. It makes sure that all the replicas are updated. Okay.
How do we know that we are modifying a main block or the others?
That's what, see, that's why we have Hadoop. No, you don't need to worry about all these things.
Okay.
Because you being a data scientist or a data engineer, you need to focus on your program, not on this infrastructure, right? Let it be handled by Hadoop.
Okay.
Before Hadoop, all these things were handled by developers only, which was very complicated.
Okay. Like one more thing, like if new block is formed, so it will be formed with replications also, or just only that particular new block?
No. As soon as a block is created, within milliseconds or microseconds, two more blocks gets created.
Okay.
Immediately it happens. You don't need to wait, or you don't need to say about it. Hadoop intelligence, no?
Okay.
Sir, can we add number of replicas?
Sorry, I didn't get it. What?
Can we add the number of replicas?
Means you are saying instead of 3, make it 5?
Yes.
Okay, yes. Means, see, ideally as a developer, you should not play with all these things, like what is the default size of a block, how many replicas should be created. You should never do that. But if you want, yes, you can even control the size of the block and the number of blocks. For example, you say, oh, I don't want to do replication, so only the main block will be there. You say, I want to have 5 replication. That can also happen. But all of these things have their own repercussions. For example, if for any given block, you say, I don't want to do replication, then there is no fault tolerance, right? You are compromising on the fault tolerance. If any fault happen, your data is lost, right? If you say for any block instead of 3, you say replication factor should be 5. You say, oh, I am making my system very fault tolerant. In this case, instead of 3, you are having 1. So there was no fault tolerance, right? But here you say, Rahul, I am having 5 blocks, which is huge fault tolerance, because 5 machines will contain that. But don't you see that if there was 1 terabyte file, you were storing it, you were consuming 3 terabyte space. But if you make 5 as the replication factor, you are consuming 5 terabyte of the space. Because
Yes, sir.
ultimately the file will be replicated 5 times. No? Blocks getting replicated is same as file getting replicated. So you are wasting too much of system resources, right? Storage space. So everything has its own repercussions. That's why this 3 is a very intelligent value, with the concept of rack awareness also, that 2 copies will be on the same rack, 3rd copy will be on the another rack. So don't play with these things, but yes, you can.
Okay, sir.
You can increase or decrease the replication as well. Let me show you. There is a command. 1 second. We will do these commands today. See, the replication factor is a property that can be set in HDFS configuration file So in HDFS, normally it's already configured. You don't play with it. However, there is a command. You can check the replication factor of the system and you can change it also. But I'm saying I am not recommending you. So we will talk about this today. So this set rep is setting the replication factor. So for example, you want to store a file.txt in Hadoop, but while storing this file, you are saying convert its replication factor, change its replication factor to 3. Okay. Or to change it to 2. So you can do this. You can change it to 1 also. So there are commands, but again, these are not recommended. Okay, but yes, using commands, you can change the replication factor of a file. Or even for a directory also, using setrep command. Okay, we should not do this, but yes. What is another question, sir? As you said, there will be one original data block and 2 more copies, but what if all the 3 blocks stop working? Okay, Shivali, again, very good question. Wait. So we are talking about, see, मैं आपको Hadoop architecture बता रहा था, मैं आपको Hadoop architecture बता रहा था, मैं आप लोगों को Hadoop का आर्किटेक्चर बता रहा था जिसमें आपका नेम नोड और डेटा नोड्स होते हैं. बट अब आप लोग कहाँ जा चुके हो? आप लोग HDFS के आर्किटेक्चर में जा चुके हैं. अंडरस्टैंड इट. Hadoop का आर्किटेक्चर कहता है कि भैया नेम नोड है, डेटा नोड है, चलो खत्म काम, रैक्स हैं, खत्म काम. बट ये जो भी हम सारी बात कर रहे हैं वो HDFS का आर्किटेक्चर है. ये जो आप देख रहे हैं यहाँ HDFS का आर्किटेक्चर है. मतलब Hadoop में जो फाइल्स होती हैं वो कैसे काम करती हैं कि वो ब्लॉक्स में स्प्लिटेड होती हैं, उनका रेप्लिकेशन फैक्टर होता है, रैक कॉन्सेप्ट है, मेटा डेटा है. ठीक है. हाँ, तो मैं आप लोगों को एक इंपॉर्टेंट चीज यहाँ ये बताना चाह रहा हूँ. 1 मिनट कहाँ गया? हाँ, ब्लॉक रेप्लिकेशन की बात तो हमने कर ही ली है. ठीक है, डेटा रेप्लिकेशन आप पढ़ लेना. डेटा नोड्स हैं ये पीली वाली, ऑल दिस येलो आर द डेटा नोड्स, ग्रीन्स आर द ब्लॉक्स. So now Shivali asked a question which is that, oh Rahul, you are saying that 1 data node goes down, 2 data node goes down. What if all the 3 data node goes down which contains the replica? Then the data is lost, right? No. Then there is something known as re-replication. Data, disk failure and heartbeats and re-replication. Very, very important. And something known as cluster rebalancing. What is that? I have shared with you this link. You can read about it. Let me explain this. I'm saying that let's say this data node goes down, right? And there was some program which was running here. It will shift to the another data node which contain that block, right? But how will the switching happen? So what happens is, guys, there is a concept of heartbeat. Every data node sends a heartbeat to the master at an interval of 1 second. And this is a configured value. Some systems have 5 seconds. So every data node sends heartbeats, say after every 1 second. If this data node is down, it will not send any heartbeat. So name node will wait. Okay, 1 second, I haven't received. It will wait for 1 more second. Okay, I didn't get it. It will wait for 1 more second. So it waits for 3 heartbeats. If it does not get 3 simultaneous heartbeats, 1 by 1, that means 3 seconds. After 3 seconds, also, if it does not receive a heartbeat, it marks this data node as failed. And automatically the name node switches all the programs which are running here to those data nodes which contain the blocks which were there. So there is a concept of heartbeat. Every data node keeps sending their heartbeats to the name node. And if there is no 3 consecutive heartbeats received by the name node, it marks that data node as failed. Okay, that is the first thing. But name node is the master, right? So master is very intelligent. It knows that this data node is down, right? And it also knows that, for example, this data node contained a block. So what name node will do, name node always make sure that 3 copies are available in the system. So if there was a block here, which is gone, so how many blocks are left now? Only 2. So this is known as under replication. There is over replication and under replication. So if a data node goes down, so name node will mark all those blocks as under replicated, which were there. And it starts to create one more copy of those under replicated blocks on some other data node. So as to make sure always 3 copies are available. So Shivali, are you getting my point? It's not that if this data node is down, we are just relaxed. No. Name node is doing some operations behind the scene, which is to check which block is lost. It will go to its replica block, take the data from there because it needs data, right? From here, you cannot read anything. It goes to its replicated block, take that data and copy it to some other data node. So as to make sure that 3 copies are always available.
Okay.
So even if this entire rack is down, so I am only having 1 replica left, right? So system immediately starts to create 2 more copies. So that's how Hadoop, I'm saying, is it's a lot of things which happen. Shivali, is it fine?
Yes, sir.
So it will hardly ever happen that all the 3 blocks are gone. That's why we have this rack awareness. Don't keep everything on the same rack. Right? Even 1 copy will be on another rack. So that at the worst case, the entire rack is down. I still have another rack. Okay. So heartbeat and balancing and all happens. So you can read about it, heartbeats. So if any data node or disk fails, it can't send heartbeats. Right here it's saying it waits for 10 minutes to mark it as fail, but that's too much of a time. Now we don't wait for 10 minutes. It's like 5 seconds, 3 seconds, whatever. And once our data node does not send 3 heartbeats, so we say currently it's down, we'll fix it. But for the time being, do the re-replication. Means replicate the block to make sure we always have 3 copies. Okay. Any other question? So you have seen, 1 second, Hadoop architecture and HDFS architecture. Now the last thing that we will do is MapReduce architecture, but not today. This will be in some of the other class, but I'm saying this is the MapReduce architecture, how a file will be processed. This is a word count problem. We want to count the number of words, how many times each word is occurring in a file. We will do this. So how the mapping, shuffling, reducer, splitting, all this process happens. So this is a MapReduce architecture. We will talk it in like after 1 or 2 days. We will do some hands-on first. So you'd see Hadoop architecture, HDFS architecture, and then there is this MapReduce architecture. Yes, we will talk about this later. Any question? This is how a MapReduce will run. Mappers will run, reducers will run. There will be the input data, output data. We'll talk about it. Any question, guys? Yes, no?
No, sir.
Perfect, perfect. Okay. So
this replication will be done for each failures.
no, what do you mean by each failure?
Like if there in any particular block is not working, or in the whole data node is not working, so it will be done for each like any fault or The re-applications.
No. See. The read application only happens if the entire data node is down.
Okay, sir.
So if the entire data node is down, all the blocks which are there, they will be replicated, or I should say re-replicated.
Okay, sir.
But you cannot, because this machine is down, you cannot even read the data from here, right? So if this machine is down, you cannot read the data, then how will the re-replication happen? You need data, right, to replicate. So name node will have the metadata where it know that where can I get its copy. It comes to that machine, say, hey, I need to copy you because your corresponding machine is down. So it reads data from its replica, and using this replica, it creates one more replica because one machine is down, right?
So in this whole process, like the main, like original block or will be not affected.
Original block is gone, na?
Yeah, all the work is done on this replications or duplicated files. Like
See, I don't know. This data node is down, right?
Yes, sir.
In this data node, say there are 100 blocks for different files, right?
Yes, sir.
Now, I don't know whether how many were the main blocks, how many were the replica blocks. Even if one data node can contain few main blocks for some files and few replica blocks for some other files.
Okay.
So I forget about main block or replica block. You just focus on that the blocks are lost, right? Now you need more copies on some other nodes. That's it. Whether the block lost was a main block or a replica block does not matter. It was one of the block.
Sir, I asked in that context, like the modification is done on the this replicated files only, like the original are just only. You said that originals are not much, not required to modify. So,
No, I didn't get your question.
like so, I thought I guess like this original blocks will be not. We will not do any modification on that original blocks. We do whatever.
Yeah, no more. See, no modification is happening here also. We are just replicating it, na? Just taking copy as is. We are not
Okay.
modifying anything.
Okay.
If this of the block is lost, so I am just going to its replica and just taking it and copying it on another machine. I am not modifying the data here. I am just replicating it, or I should say re-replicating it. In case of node failure, I am re-replicating it, na?
I thought that each data, like there will be some data node having original data, and some data node will have only the this copied or replicated.
Yes. But for Hadoop, everything is equally important,
Okay.
whether it's the main block or the copy block. There is no
Okay.
partiality.
Okay.
It's just for the naming convention, we say, okay, one is the main block or other are the copy blocks. But there is no partiality. A block is a block.
Okay.
So we have talked about Hadoop architecture. We have talked about HDFS architecture. We talk about all this replication, fault tolerance, block operations and all. Okay. Map reduce architecture comes later. There is one important thing that we are saying Hadoop is fault tolerant. Fault tolerant means it tolerates the failures. Means if any of the data node goes down, you have the replica. In interview, they ask that Hadoop is fault tolerant. Why? Because of the data nodes, block replication, RAG awareness, all this. But we have only one node, right? What if the name node goes down? Did anyone thought? I'm saying, okay, one data node goes down, we will replicate all these blocks to some other data node. Okay. We have too many data nodes, hundreds, but we have only one master. It can also go down, right? It does not have such immunity, right? That it cannot go down. So for that, this is the primary name node. We have a secondary name node also. We have a secondary name node. Let's see that. So in the Hadoop, this is Hadoop architecture again. So Hadoop. If you see this, very important. I am saying that, okay, we have a name node. This name node always have just metadata, right? Metadata means file, how many blocks it contains, on block locations, and the number of replicas. So this is the metadata, but the actual data is stored on the data nodes in the form of the data blocks, right? Clients can come to read and write the data. They'll talk to the name node to read and write the data. But see, we have a secondary name node. So this is the primary name node. If the primary name node in some case goes down, we have a secondary name node. What happens is, from time to time, primary name node keeps sending its data to the secondary name node, so that all this metadata, the primary name node keeps sharing with the secondary name node. And if the primary name node is down, secondary name node contain all the information, means all the metadata. So we have to manually just come and make it as a primary name node. And meanwhile, we keep working to fix the problems, whatever happened. For example, it failed due to RAM. So we will come and add more RAM. But our cluster should not be down, right? So secondary name node will play the role of the primary name node till the time we fix this issue. Okay. So we always have a secondary name node. There is one more thing. I am again and again saying that Hadoop is very cheap cluster. Hadoop is very cheap cluster. Means the data nodes are very cheap machines. They are not very server grade machines. They are like our laptops. So they can crash because of RAM, because of hard disk, anything. Nodes are here. We know that they will fail. That's why we have built a fault tolerant mechanism. But the name node is always a costly machine. It is always a very costly machine, so that it never fails. So if this one data node will cost you say 1 lakh rupees, this may cost you 10 lakh rupees. Just for example, data nodes may be like 1 lakh rupees machine, but a name node will be like 10 lakh or even 50 lakh rupees machine with huge RAM, huge memory, huge infrastructure setup, so as to make it a fault tolerant, that it does not go down. But still, in the worst case, if it goes down, we have a secondary name node. So our name nodes are always costly enterprise grade machines, but data nodes are cheap commodity machines. They are commodity machines, cheap machines. Any question? Okay. So with this, I'll go hands on now. 1 second. Okay, guys. Sorry. So now what we will do the hands-on. Yeah, go ahead.
So the secondary name node also count in the total number of nodes. Like if we said if there is 100 nodes, so one will be master and so other will be.
Yeah. There is no definite answer to this. That's a good point. Normally, when we say okay 100 node cluster, we say 100 data nodes.
Okay.
plus one name node plus one secondary name node. So 102.
Okay.
But it depends upon company to company. Some will say, okay, 100 nodes total means one name node, one secondary name node, and 98 data nodes. So that depends from people to people how they want to tell it.
Okay.
But normally, okay, if someone say, okay, 100 node cluster, I say 100 data nodes. It's what I use. Because ultimately name node and secondary name node are not part of your storage layer, right? They are the metadata systems. So start your and protein, I hope it works for you now, or any issues. Okay, so as I tell to all of you, I will be using cloud computing for Hadoop. So I am going to Amazon cloud. I'll go to EMR, which is their own Hadoop. Like you guys are using Cloudera's Hadoop. I am using Amazon's Hadoop, which is EMR, which internally use Apache Hadoop. We talked a lot about this. EMR itself is just a wrapper. Internally, it uses Apache Hadoop only. So I'm asking Amazon to give me some of the machines on its cluster somewhere in North Virginia. So it will create this cluster in North Virginia for me. Once the cluster is created, I will use putty tool to remotely log in. So what I will use, I will simply, I explained you all earlier also. I will be using the putty tool. So I am using putty to remotely log into that machine which is somewhere in North Virginia. So I just create cluster. Now somewhere in North Virginia, they are creating my data, my cluster, which contains one machine. I am only using one machine here, but ideally we should have minimum 3 machines, and more than that can also be there. Minimum we need 3 data nodes. Minimum 3 data nodes. Okay, because 3 is the replication factor. Minimum 3 replication factor should be there. But I am using, if you see, only one. So I'm using one master node and one data node, 2 nodes. But only one data node I'm using. This is name node, the master node. Huh? So this cluster is starting, and then I'll connect to it once it is started. So please start your virtual machines. Let me show you GCP also. I told you guys that Google also had their own cloud. We saw it in the previous class. Meanwhile, it's just starting. I just want to give you this perspective. And let me open Azure also. I hope you know about Azure, right? Microsoft Azure. You heard about it at least. So I will create Hadoop cluster for you guys. One on Amazon cloud, one on Google cloud, one on Azure cloud. So this is Amazon cloud. Now let's go to Google cloud. This is Google cloud, GCP. Here on the left hand side, if I click, okay. It's using some other account. One second. How should I switch it? Okay, anyways, leave it. So this machine is started on AWS. I'm not able to log into GCP somehow, but leave it. Let me go to Azure. Okay, I have logged in. So on the Google, if you go to a company, nowadays companies don't use much of Cloudera or Hortonworks kind of Hadoop platforms. They uses either Amazon Cloud, Google Cloud, or Microsoft Cloud, either of the three. Remember. So that's why I am showing you. If your company uses Google Cloud and ask you to access their Hadoop, but Hadoop is running on cloud, then you log into your Google Cloud platform, and here you will see this data proc. In the data proc, you will come to clusters, Hadoop clusters. You click on that. Guys, am I audible? And my screen is visible because I just switched my network.
Yes, sir.
Yes, sir.
Yes, sir.
Perfect, perfect. I just switched one network. Yeah, so I explained you in the previous class also that instead of using virtual machines, today we use cloud. This is Google Cloud. On the Google Cloud, you come to Dataproc, which is nothing but their own Hadoop clusters. You just click on the create cluster. So you create on the create cluster. You just see again, select how many machines you want. One master and n workers means multiple data nodes. One master, no data nodes. Three masters. See here it's saying three masters means three name nodes. This will be very costly. Matlab, for a very high availability, it's saying not only primary and secondary, it's saying three primary name nodes, which is very costly. Here this one master node actually will have secondary name nodes automatically attached, but three master means three primary name nodes, which is one of the latest concept, high availability, but it is very costly. Okay, but let me just, for your demo, I am saying it's a single node cluster, even only master, no worker. Master will store data also, metadata also. It's just for proof of concepts. For demos, we use this. If I want Anaconda, it will install Anaconda also, as I explained you earlier. All the softwares will be installed for me on this cluster. So it's just creating the cluster for me. So here, if you see, the now this cluster is getting created in the Google data center. This cluster is getting created somewhere in Google data center in US Central America, somewhere in Central America. If you see US Central, somewhere in Central America, it is getting created. Here, what I selected, let's see. Here I was selecting East Coast in US, East Coast, West Coast. So, but there I am selecting Central America, like North Virginia, California. So all this West Coast, East Coast, Central America. Now let's go to Microsoft Cloud. So in the Microsoft Azure platform, it's all same process. Just name of the tool is different. Meanwhile, please ping me if your virtual machine is started. See, in today's world, Microsoft Azure and Amazon, they are the two best ones. Google Cloud is not that famous. Either Amazon Cloud or Azure Cloud. They are the best if you have to learn. Amazon Cloud and Azure Cloud. See, on the Microsoft Azure Cloud, if I ask you to create a Hadoop cluster, if I ask you to create a Hadoop cluster here on Azure Cloud, so we have multiple things available. So here we HD Insight. It is Microsoft own distribution of Hadoop known as HD Insight. So you want to create HD Insight cluster, you will say, okay, create a HD Insight cluster. So if you go to a company which works on the Microsoft Azure, you just come here. Ideally, you don't create cluster. You will already get a cluster which is there. But in case you have to create it simple, you are creating a Hadoop cluster which contains Spark. I was saying no, MapReduce, Spark, Hadoop, a Kafka, Storm. These are the tools it will have. I give a name to the cluster PGA12, in which East Coast, West Coast, where you want. See, what is the type of the cluster you want to create? You want to create a Hadoop cluster which contains MapReduce, Hive, MapReduce, Hive. Hive is what? SQL. It's a SQL on Hadoop. Take Scoop, Uzi. Or you want Spark, you want Kafka, you want HBase, what you want? You say, oh, I need only Hadoop. I need Hadoop, select Hadoop. So you click on this cluster type, this window will pop up. You click select, you selected Hadoop. You give some username, passwords to it. That okay. Give some username, password to it. And then you say, okay, review and create. It will just create. Where required information is missing or not valid. So this is what I am telling you guys, that there is some free tier. If you consume the free tier, you have to pay this much. For example, here 47 rupees per hour for this one machine. If you say you need 100 machine clusters, see, if this is your work master node. So it's having two master node, say one primary, one secondary. Zookeeper node, something else. But see how many workers you want. You want to create a 100 node cluster, so you have to pay 4,000 rupees per hour. But just for this demo, I'll say I need only one machine, means I'll pay 47 rupees per hour. You're getting it. This cost is directly related how many master head nodes, how many worker node. Ignore this. You will, don't worry about this. Master and how many worker nodes you need. And just you say, okay, review and create, it will create it. So I'll be paying how much? 94 rupees per hour. And even I am under free trial, but still it's asking me to charge this much. So you're getting it. Even within free trial, you have to pay sometimes some money. So you should be aware about it. Okay, let's go back. Any questions so far? I showed you Amazon Cloud, Google Cloud, and Microsoft Cloud. Everything is simple. Any question? Yeah, Ritik, name node stores metadata, na? Data about data, which is more important than data. So Ritik, you are getting my point. Name nodes are more important than data node. Abhi isme some change needs to be done, but yeah. Ritik, are you getting my point? Name nodes are more important than data node because they contain metadata, and we cannot afford the failure of name nodes. Ritik, any doubt? Okay, guys. So let me move ahead now. So I will connect through Putty to this remote machine, which is created by me. So all of us will be doing one hands-on now. What we will be doing, guys, is we will be downloading a file from internet. Hey, what happened? We will be downloading a file from internet and we'll do some operations to store this file in Hadoop. See, sometimes what happens is you may not be able to connect to the remote machine, maybe because it's starting or there may be some problem with that machine. It must be starting. So what you can do is, guys, am I audible? Because I think my network is having some issues.
Yes, sir.
Yes,
Okay,
sir.
okay. Yeah. I just want to check it because, yeah, this website is down. 1 minute. Why is it down? That's why it's not able to connect because of some slow network. Let me try again. If the Amazon cluster does not come up, I already have a Google cluster. I will use Google cluster. Huh? Don't worry about that. So what I have done, guys, I have started this Google cluster, no? The Google's Data Pro cluster. So this is the terminal. I already opened their terminal. I will show you the hands-on from here also. So meanwhile, let's use the Hadoop cluster on Google Cloud. So what I'm doing, ls is the command to list the files, right? ls, ll, like that. But now what I want you to do is, there is a GitHub Titanic file. There is a Titanic data set, which is say somewhere over the internet. So whenever you go to any GitHub website and you want this data to be downloaded, you click on this raw option, okay? Whenever on the GitHub you want any data, click on the raw. So this is the data that I want in my Hadoop system. So copy this URL, and then what you will do, there is a command known as wget. Okay guys, wget means webget, and paste that path here. So what this command will do, whenever in Hadoop you want to download the data from internet, you will use wget command and the path of the file and enter. So just do this, please. Let me share the command to all of you. In your virtual machines, just run this command. Okay, Ritvik. Pankaj, Cloudera can provide thousands of data nodes. If the point is you are running Cloudera on your single laptop, no? So that's why you have only one data node. Cloudera can provide thousands of data nodes also, but it's on your single laptop, no? So guys, first of all, what we are doing, we are downloading a file from internet. After you have downloaded the file, just do ls and you will see this file here.
Excuse me, sir.
Yes.
So my virtual machine isn't open yet. Still if open.
No problem. Let it open. But meanwhile, I'm just moving ahead. I'll repeat it. So please follow along, guys. I'm saying that whenever you are working on Linux, right? You are working on Linux, or you are working on Hadoop. wget is the command to fetch the data from internet. So it will connect to the internet and download the file. So if you see, this titanic.csv is the file which is there. This file is nothing but this entire data which you see on the internet. It is downloaded. So you need to be connected through internet. Huh? Only once you are connected to internet, then only this wget command will work. Now this file is available in Linux. Remember, this file is available in Linux. So let's see its content using more command. More is one of the command using which you can see the content of a file. I shared with you guys my Linux link. I don't know if you have practiced it or not, but there you have all these things.
Excuse me, sir.
One second. So using more command, you can see that yes, the file is downloaded. This file is downloaded. And the benefit of more command is it shows you like first 1% of the data, then keep pressing enter, and you will see more data. Just enter. You will see more data. Yes, tell me.
Sir, actually,
What's the
I'm not
question?
able to switch the tabs between Linux and Windows.
Okay. Because I think on Windows you need to attend this session, right?
Yes, sir. Right now I'm logged in through my phone, but my laptop is not responding in a good way.
So for those having this issue, yeah, you have to do it only means connect through phone for the class and practice on that machine.
But sir, I'm not able to open the Google Chrome also. So
No. So I told you, someone is saying Control Alt. Press Control Alt.
okay.
There are certain shortcuts. Or else you can practice after the class. That's fine. Okay, so guys, those who are able to do it, please confirm. wget, they downloaded a file. Then using ls, they checked that yeah, file is there. And then using the more command or even the cat command, I told you cat command, they can see the content of the file, right? So to view the content of a file, we have multiple approaches: cat command, more command, and then there is a head command. Head command shows the first 10 records of a file. Head command shows the first 10 records of a file. So guys, understand that this file is on Linux. Still, this file is not on Hadoop. I will tell you what I mean by this. Lokesh, can you please go on mute? Okay. So guys, I am just waiting for all of you to ping me. Once the data is imported.
Sir, I'm not able to import the data.
Sir, can I share my screen? Sir, you're not audible.
Hey guys, I'm back. I don't know how I got disconnected. Yeah, let me again share this. Yeah, so what I'm saying is I showed you 3 commands. Cat command, which
Excuse me, sir.
displays one second. Cat command, which displays the entire data. Uh, then more command, which is the best. You keep pressing enter, enter, enter to see the data. Or head command just to see the first 10 rows. Yes, tell me.
Sir, can I share my screen?
Yeah, it's hanging, I think. But yeah, share. Yes.
Sir, I think it's imported 3 times.
Delete na, delete. Why you keep 3? Keep only 1.
Sir, how do I delete it?
Just you have clicked on it na, press the delete button on the keyboard. Delete button. Delete from the disk. Yes, delete from the disk, because you are consuming 15 GB or what, only 50 GB 3 times. So why you need this much? Delete it. Your system resources are unnecessarily. Just only this now. Yeah, now. Yeah, wait. Just added virtual machine settings. 2 core 7 GB. Make it 7,000. Don't give 7 GB. If your system works fine, then you can increase it, but 7,000 is good enough. Yeah, just okay. Yeah, play. Now it will start in just 4-5 minutes. Cannot connect to the, because no connecting device is available in the host. Do you this every time? One, do you want to try to connect this virtual device every time you power on the virtual machine? Yes. Make it yes. It's just starting the device.
Sir, how do I download the data?
You have to first go inside, na? Inside this only you will be accessing the terminal. Let it start. Click alt tab. Just click somewhere on the screen and then press alt tab. Have you done that?
Yes, sir.
No problem. I think something is happening. But yeah, it's starting behind the scene. The Hadoop is getting started. I just wanted to show you the logs, but let's wait. It's almost done. Your Hadoop, it's just booting up. So we will use this virtual machine only for the first 2 weeks. After the next 2 weeks, we will use some online tools. I will give you access to that. And you don't need this virtual machine then. But I want to make sure you guys know about virtual machines as well. So honey, it will start in a while. Huh? So can I move ahead?
Yes, sir.
Yeah, please stop the sharing. Anyone who is facing any problem want me to look into?
I'm not able to import the data.
Share your screen. wget space the path space the path. You don't need to copy paste from outside now. Access the internet here itself. You have the internet. Yeah, access this. Yeah, do it. Now here type Titanic GitHub Titanic file. Yeah, just type GitHub Titanic dataset. File whatever. Enter. Just click on the first link. Yeah, that's fine. Yeah, click on raw. No, below. Yeah, raw. Click. Copy this URL. Just paste it there with the wget command. Right click. Don't use Control C, Control V here. Huh?
Yes.
Right click, paste. Enter. Done. ls. See the last file titanic.csv. Now use the more command. Space T and then tab. T and then press tab. Yeah, it autofill the file name. Enter.
Okay.
Keep pressing enter. You want to come out of it, press Q. But that's it. Do LL. This is long listing. So it shows you who created the file when. Third last file.
Okay.
Perfect.
Thank you.
But see, even though you are using virtual machine, this file is still on Linux. Still, this file is not stored in Hadoop. Means this file is not replicated. This file is not splitted into blocks. This file is still on the Linux, not on HDFS. So we have to move this file from Linux to HDFS, which I will explain you.
Yes, sir.
Okay, stop the control. Give the control to me. Anyone, any other person doubt? So now I'm able to connect to Amazon also. I'm able to connect to Google also. Both are working fine. Anyways, but let me go to my Amazon cloud, which is this. And where is that file? Here is the file, right? So if I do ls, I have nothing as of now. If I do wget and paste this, it downloaded the file, and see I got this file Titanic. I will use more command, more or cat or head or whatever to see its content, right? But now the question is, guys, that even if using head, I'll see this file. This file contain header, but I don't need header, right? I want to remove the header, for example. So currently we are doing again Linux and shell scripting. This is Linux, this is shell scripting. We'll keep doing it. So how to remove the header? How to remove the header from a file using Linux? See, I told you about WC command, which is word count. So what you will do, 892. So there are 892 records, right? Very good. Head command reads data from top. Tail command reads data from bottom. The last, see 891 like this, the last 10 records. So what I will do, I'll say Titanic tail 891 of Titanic. So what this will do, tail command will read data from bottom. It keep going up till the 891th record, not 892. So it will skip the header. So And this data I will move into a new file. Say new Titanic. I'll explain you this. But if you see now, data is starting from 1, 2, 3, 4, 5 like this. Header is removed. But if you see the original file, the header was there. So I'll share with you the command first before we do. So I'm sharing the command. You just see and write it. You won't be able to copy paste. Just see it and type it. So what we are doing, we are creating one new file from the older file, but taking the out of 892 records, only 891 records from the bottom. We are starting to read the data from the bottom, not from the top. So Madhu, tell me one thing, like how much RAM you have? 8 GB. So you give it a lesser amount, like I think give 6.5 to virtual machine and then try to run it. But while you are working on it, don't means do this practice after the class. During
Okay.
you can connect it through mobile, connect the class from mobile and do the hands on your laptop if you want.
Okay.
You can see the screen share in the mobile and practice it on the laptop, but don't use both things on the laptop. Or at best you practice after the class. Okay, but don't switch between two windows if it's hanging. Okay, so guys, are you with me? Have you using the old Titanic file? We use tail command to read data from bottom, keep coming up till the 891th record and skip the top record because we are moving from the bottom to up. So all that data we have moved into a new file. This is the command. This arrow moves data from the left side to the right side. So please confirm if you have generated the new file. Okay, Kataki, thanks. Let me wait for a few more people. Okay, perfect. You can do it after the class also, but let me move to the next most important thing. Yukti says command not found. Yukti, please quickly share your screen. It's loading. 1 minute. No. So Yukti, what you are doing? How can you write the name of a file? You have to cat, na? This new Titanic is the file. Is the new file. So you have to see its content using say head command. Use head, and the name of the file. So you were just typing the file name. No, see, perfect. Okay. So I hope it's done. Now I'll come to the most important concept. This consider is like your cluster. This is one data node. This is another data node, right? Multiple data nodes. So you have. So currently using putty tool, I am connected to one of the machine, guys, and understand it. You using putty, I connected to only one machine. I can connect to any one machine. I cannot connect to more than one machine, right? So for example, this machine is what you see on my screen, this one terminal. So every machine, every data node actually have two parts. One is local file system and one is Hadoop file system. Every machine, every data node have two parts, local file system and Hadoop file system. So for example, if I store any file here, so this will also have a local file system and a Hadoop file system, okay? So if I store any file here, guys, using say any way, or I create a file here, and tomorrow I want to connect to this machine, I won't be able to see that file here. No. But if I move this file from here to Hadoop, get it, understand it, then even if I connect to this machine, I can access this file which was here from here also, because it's in Hadoop, it gets replicated and the information is stored with the name node. But the local files are local to this data node. They are not part of Hadoop system. They are not replicated. They are not managed by the name node. They are only managed by that data node. Are you getting it? Every machine have a local file system and a Hadoop file system. Any file which is created in the local file system will remain in the local file system only. And tomorrow if this machine fails, you cannot retrieve the local files, never. But if smartly you move these local files into these Hadoop files here, I'll tell you how to do that. Then this file will be replicated across the clusters, split it across the cluster, maintained by the name node. So if this cluster goes down, any file which is here in the Hadoop side will be recoverable, but any file which is here will never be recoverable. Same is the case, any file stored on the local side will not be recoverable. If from here you move file here, they will be recoverable because they will be replicated and distributed across the cluster. Are you getting this point? Yes, no?
Yes, sir.
Perfect. So let's see that in action. So currently, if you guys look at what I did, I created this Hadoop cluster, right, with the name of PGA12. I had two machines, master machine and the core machine. I can connect to either of these machines. Even if I have hundreds of data nodes, I can connect to any one machine and that's done. So I connected to one of the IP address, one of the machine. So this is one of the machine in my cluster. It can be a data node, it can be name node. Don't worry about that. But ideally, I am logged into say one of the data node. But once you log into the data node using PuTTY or any such tool, even on your virtual machines, the terminals that you have opened is the local file system. So whenever you are typing ls, it's the Linux command ls. But if you want to see the files which are present on Hadoop, you have to say Hadoop fs, which is Hadoop file system, and then you have to say -ls. See, even currently we haven't moved anything on Hadoop, so there is nothing present on the Hadoop. So consider this ls command was Linux command. This ls command you want to run, but not on Linux, but on Hadoop. So you have to always prefix it with this word Hadoop fs -ls. Let me do something like this. So these are the files which are currently present on Hadoop. See, HDFS, HDFS, HDFS. These files are present on Hadoop, all these. So let me ping you this command. We will move files from Linux to Hadoop, but first see. Currently, these are some of the files which are there. So first command will not give you any result, but this command will give you this result. So this is the way to see the data which is on Hadoop. So if this is your data node, and this is local file system, and this is Hadoop file system. So this ls command is running here, whereas this command is looking the data which is here on the HDFS or Hadoop file system. It's Hadoop file system. So Hadoop FS is mandatory. After that, you can write any Linux command with a hyphen, ls, cat, vat, anything. We will see that. Okay. So let's move ahead. Now, what I want is, I want to move file from the local Linux to Hadoop so that it gets distributed across the cluster and I can access it anywhere. So first of all, ls karke we'll check the file which is on the local Linux. And now you have to move it to Hadoop, right? So Hadoop fs -put. Put is the command to put files from local to Hadoop. And then there is a get command, put command and get command. Put to put file, get to get it from Hadoop to Linux. You have a file in Hadoop, you want to bring it on Linux, you can do that also. So put command and get command. So Hadoop fs -put, give the name of the file and the target on Hadoop where you want to move it. So let's say I want to move inside this user directory. So what I have done, I have put this file from the local, from the source to this target location. Target location is this. Okay, this is the Hadoop location. So now I will again use this command, Hadoop fs -ls, ls has to list the files, and again on the root, this is known as root. So here you don't see that file, right? That file is not here. Why? Because file is moved inside this directory, inside this user directory. So I need to type user here and check inside that user directory. See, titanic.csv file is there. So let me again tell you, if this is the data node, when I am doing ls command, this Titanic file is on the local Linux. When I'm running this command, Hadoop fs -ls, I am checking on the Hadoop. Now there is no, the file is here, but not here. I have to put it in HDFS, right? So Hadoop fs -put, put this local file to this Hadoop path. So from here, move it here using the put command. So the file from here will be moved here to a specific path. And when I go inside that path, Hadoop fs -ls, to see that file is present. That file is present here. See, this is Hadoop. So let me ping you the commands. So just see how to move files from local to Hadoop. Huh? So far we were learning Linux commands. These are known as Hadoop commands. If you have looked at the agenda of today's class, Hadoop commands was part of it. So this Hadoop commands works only on the Hadoop machines. On normal Linux machines, they will not work. So your machine should be Hadoop machines, data nodes, then only these commands will run. And those who want to study these commands, they go to Google and just type Hadoop commands. Don't type Linux commands. These are not Linux commands, okay? These are Hadoop commands. So You can go through any of these links. That's not the point. I prefer this. Yeah. So you will get all of those commands there. Okay, good. There is one more thing. Let me tell you. There is another version of writing it. One second. So on some of the websites, when you will be studying it, no, instead of Hadoop FS, some people will be using this prefix HDFS space DFS. But this is an older syntax. Means this is just a prefix. You have to always put it. HDFS DFS means Hadoop distributed file system. But we don't prefer it now. We just write Hadoop FS, Hadoop file system commands. Okay, but I'm just telling you, like on this link, if you come, here you will see 41 commands with HDFS DFS. See HDFS DFS commands. So there are a lot of HDFS DFS commands here. But this is what I prefer. This is the latest way. Hadoop FS, then you want to create a directory in Hadoop, then hyphen mkdir to create a directory in Hadoop. Then hyphen ls, the one I'm showing you how to see the files, list the files inside a particular Hadoop directory, not Linux directory. So, and then put command, right, to put data to Hadoop. Then there will be get command to get data from Hadoop. Okay. So let me share my GitHub link where you will find all these commands. So guys, please practice Linux and Hadoop commands, because we will be moving into more programming, SQL and Python after a couple of days. Okay, where is Hadoop? Yeah, this is Hadoop concepts. So here you have Linux and HDFS commands, right? On 19july.txt. Let me show you. Yeah. So here you have certain commands, right? This line number 13, it's a Linux command. It's not a Hadoop command, but this is a Hadoop command. So any command which have HDFS DFS written before it, or Hadoop FS instead of HDFS DFS, you can write Hadoop FS. That is a Hadoop command. For example, this is a Linux command because it does not have a prefix. These are all Linux commands. But this is a Hadoop command. This is again a Linux command, right? All these commands, right, which I just showed you guys, right? So please do practice this. So let me share this link. You can follow this as is. Please try to put a file on Hadoop and tell me if it is done. I'm just waiting. Please practice it, comprehend this, what is this idea. So far only 2 people have pinged. Okay, so you can use put and get commands and all these things. Guys, any questions or can I move ahead? Just ping yes if so that I can move ahead. Okay, perfect. So we now know that every data node or even the name node have two parts. One is where they have the local Linux, one is the HDFS. So you have to move between the local Linux to Hadoop, Hadoop to local Linux. This is how you keep working. Any file which is in the local Linux cannot be accessed through other data nodes. But any file that you have moved to HDFS, it will immediately be splitted into small blocks and replicated across the cluster. So unless you have files like ls, for example, both these files, they don't provide you fault tolerance, they don't provide you high availability. If this cluster is down, or sorry, if this data node is down, these machines will be lost permanently. But if you move both of this to the HDFS using HDFS DFS-put, this file is splitted, distributed across the cluster. So these files are locally stored, whereas this file, the one that you moved and checked, right? This is not locally, this is distributed across the cluster. Sorry. But even you won't be able to know that in how many data blocks this got splitted or which machine contains it. You don't know as a developer. As an admin, you can check. As an admin, you can check how many blocks it contains and which block is on which data node. You, as an admin, you can do that. However, if you see this file, the size of this file is just a 60 KB file. It's a 60 KB file, right? So 60 KB block size is how much? 128 MB. So only one block will be there for this particular file. There will be only one block, and that's to only 60 KB. This file does not exceed 128 MB. So there is no point of having multiple blocks. Getting it? Yes or no? So this file will be stored in one block, HDFS block. Guys, yes, no?
Yes, sir.
Please be interactive because I cannot really see. Okay, so there are some commands, admin level commands, using which you can even check that also. Let me check. These are HDFS, DFS admin commands. So if you look at, there are some admin commands. You will never be using these commands, but I'm just telling you for your sake. You will never even have the access to run these commands, but here you can because you own this cluster. HDFS DFS admin, or you can say Hadoop FS admin. So HDFS DFS admin command -report, it generates a report. This is known as block report. This is the full report of your Hadoop system. So what it is saying, see, blocks with corrupt replicas. How many blocks are there? See, under replicated blocks. Remember I was telling you. So let me check, where are these? Aha. So see what it's saying, your HDFS space remaining total capacity is 57 GB. Like for this data node, as I told you, right? This is the data node. It has two storage parts. One is local, one is Hadoop. So the Hadoop, how much storage space is given to Hadoop? Only 57 GB. So this part is 57 GB. This may be some other 10-20 GB. Out of that, you have currently used 862 MB. 1% is used. Okay. And currently it's not showing how many blocks. Let's consider you have 100 blocks. Let's consider. Each of this block will have 3 copies, right? If there are 100 blocks, each of them will have 3 copies. So it's saying under replicated blocks, 0. Under replicated blocks will be those blocks out of this 100 which have less than 3 replicas. Blocks with less than 3 replica are known as under replicated. Blocks with more than 3 replicas are known as over replicated, which is not good. Huh? Blocks with corrupt replicas means, let's say for one block there were 3 copies, 1, 2 and 3, but somehow this copy is corrupt. When I say corrupt, means it may not be accessible. This file is not readable, this block is not readable, so that is like corrupt. It is not under replicated, it is there, but somehow I'm not able to read it. Maybe some problem. Missing blocks. Are there any data lost? So these kinds of things you can see definitely. Live data nodes. How many data nodes are currently live? Only one. I have one master node, one data node. So it's not showing two because one is master node. So only one data node is live. So this is about, see, this is known as block report. The report about the blocks. How many blocks are there? How many are under replicated, over replicated? All these things you can check. So some people will say the DFS and the non-DFS, like non-DFS. Non-DFS is like Linux. DFS and non-DFS. So non-DFS is the Linux part of that machine. Okay. Now, if you want to see at the file level, again, these are not normal commands, these are advanced commands. If you not get it, that's fine. But if you want to see at the file level, that file is divided into how many blocks and how many, what is the replication factor for the file. So we have a FSCK command known as file system check command. HDFS FSCK, which is file system check command, so just remember this simple command. I'm pinging again. HDFS file system check command. See what it's showing you. It's showing it's connecting to the name node because you want metadata. Understand it. You want metadata. You don't need data. So metadata is stored in the name node. It goes to the name node, fetches the information about the file, and shows you that this file is currently in a healthy state, means this file is not corrupt. The file under this path is healthy. Why it's healthy? Because see, how many blocks? Only one block. I told you, only one block. And what is the size of the block? 60 MB, so 60 KB. 60 KB ka file hai ye, or only one block. Are there any over replication? No. Are there any under replication? No. Are any missing blocks? No. What is the default replication? See, the default replication factor is 1, but ideally it's 3. Because I have only one data node, so the replication factor cannot be more than 1. But I can increase it. That's not a problem. So what is the block replication? It's just 1. Any missing replica? No. Any corrupt replica? No. How many data nodes we have? 1. How many racks we have? 1. Because we have only one data node, it's in one rack. If I would have multiple data nodes, they would have been in multiple racks. So are you getting these commands, guys? These are some advanced commands, but this is about the files when they are moved in Hadoop. So this is Hadoop file system check. Any question on this block report? This is known as block report. Report about the blocks for a given file. So one is HDFS admin command and one is the file system check for a particular file. If you have to do for a particular file, this is the command. If you want to see the block report for a particular file. If you want to see the block report for entire Hadoop, then this is the command. HDFS DFS admin -report. So these are all Hadoop commands, which was the agenda of the day. How to move files from Linux to Hadoop, Hadoop to Linux. Practice more. We'll talk about it. But yeah, any questions? How do we know the path of Hadoop, or it's always a user? Okay, very good, very good. So I'll just end today's class with Pankaj's question. See, whenever you are running this command, HDFS DFS -ls, it's not returning you anything, right? It's not returning you anything. But as soon as you type this, let's see what happens. It returns you something. Why? What is this symbol? Anyone know? This symbol is known as root directory in Linux. Let me explain you. This symbol means root directory, and inside this root directory, this is the top level directory in HDFS. I will say Rahul, let's say Lokesh, okay, let's say Pranav. So inside this root directory, I have 3 subdirectories: Rahul, Lokesh, and Pranav. Now inside Rahul's directory, I can have a subdirectory as trainer, right? But that is inside Rahul. Inside Lokesh, I have a directory, say, known as a student, right? Now, if I ask you to put a file in Rahul folder, so you will say HDFS DFS -put, and let's say this is the file that you need to put. Now, where you want to put? If you say this, if you just say this, guys, then that file will be present here. Titanic.csv. Consider parallel to Rahul, Lokesh, and Pranav, this file will be present here. This will be a file. These were directories. Remember, these were directories, but here this is a file, because you say put this file in the root directory. So root directory is this. So parallel to Pranav and Rahul and Lokesh, this file will be present. But if you say no, I don't want to put it in the root directory, I want to put it inside Rahul directory. So then this file, instead of here, where will it go? It will come here. Inside Rahul, this file will be there, parallel to trainer. This file is not inside trainer. This file is inside Rahul, which is parallel to this trainer folder. Because you say in the root, put it here. But now you say no, put this file under Lokesh and student folder. So you are saying on Hadoop, this is the root directory, this is the Lokesh directory. Within this is subdirectory under Lokesh directory. So put it here, means that file will be here. Titanic.csv. That will be inside this folder. Or this can also be considered like this. I can represent it like this. A nested structure, right? So guys, tell me that if I run this command, then Titanic file will be here or here. Which is correct? Row number 7 or row number 8? Row number 7 or row number 8? Output of this command. Just ping me on the screen. 7 or 8?
7.
7. I want everyone. 7. Very good. Very good. Correct. Because under Lokesh, under student, I want this, which is this. So this is the correct, not this. So if I wanted to put it here, I should have done it like this, because it should be under Lokesh. So under Lokesh, so remove this. So if I want to put it under Lokesh, I would have done it like this. So under Lokesh, parallel to student folder. So Pankaj, am I able to answer your question?
Yes, sir.
So you always, what you do, where you don't know about HDFS, right? You are accessing it for the first time. You don't know how many files and folders are already there. You don't know that, right? So always just run this command. Before even you use put get, don't do any put, don't do any get. First explore the Hadoop. So you will use ls command to show its root directory. Now in the root directory, we always should focus on the user, because we are one of the user. So now you further explore ki what is inside the user. Currently we are just exploring Hadoop. Oh wow. Under user directory, we have already Hadoop directory, history, Hive, Hue. Hue you all know, right? Hue, Uzi, root. Ye file to we moved, right? Now, let's say you are interested in this because Hadoop is the username with which I logged in. So there are multiple users. Like here you will see Rahul, Ajay, Chandan, Vikas, Akash. If your team contains 10 users, so all the users will have a directory with their name. Rahul, Akash, Chandan. Currently I have logged in with the name Hadoop. So you will see the file with the name Hadoop. Oh, sorry, the directory with the name Hadoop. So if I see Hadoop, means under the user Hadoop, is there any file? No, there is no file. So what I will do, I will say, let's make a directory in user Hadoop, or even let make it good. I want to add a new user in my team, say Rahul. So I will say HDFS DFS make directory, and in this users add new directory named Rahul. A new user Rahul has joined my team. So he is one of the users, right? Now another user join, say Lokesh. I'll create Lokesh. And then say another user join, say Ketaki. So I create Ketaki. So now for every user, they will have their own directories, so that they don't corrupt other users' directory. So let's see. So now I have Rahul, Ketaki, and Lokesh. Now say now Lokesh logged into this machine, for example. So whenever Lokesh will move any file from Linux to Hadoop, he should move files in his folder only, not in Rahul or Ketaki's folder. That is not good practice. That's why I have given a separate folder to Lokesh. Now, let's say using ls, I have this file, new Titanic, the one which does not contain header, and Lokesh want to move this file in Hadoop. So first he should know where he need to move. So he will check whether he is having a folder. Yes, we have a folder for Lokesh. So Lokesh, what he will do? HDFS DFS hyphen put which file? This is the Linux file. Where he need to put? He need to put it on Hadoop, but under his particular directory. So he will do it like this. Once file is moved, now what Lokesh will do? He need to list the files, right? He want to check whether file is moved. So he will list the file which is in his directory, all the files, and he will see, okay, yes, that file is there. Now he want to see the content. So there is a cat command to see the content. So he will use cat command. Sorry, file का नाम नहीं दिया मैंने. New Titanic. You see the file, na? Using cat command, you don't see the directory. You see the file. So you need to give the name of the file. So this is the file. Pankaj and everyone getting it?
Yes.
Shivali, you missed the space after ls. After ls, there should be a space.
Okay, sir.
Just confirm, Shivali, if it works after you just forgot that space. No?
Yes, sir.
It working?
Yes, sir.
Very good. So what Shivali did was she was just doing like this. So it will not work. No, you miss this space. That's it. But yeah, Shivali raised a good point that if she is running this, it's working fine. Without giving the HDFS directory, either root directory or user location. Yeah, ideally we should do it like this. But the point is, if I don't give any target directory, can anyone tell me what is this default Hadoop path it's looking at? It's showing you the files inside some default Hadoop path. What can be the default path? That default path is the username with which you have logged in. So if you look on the left hand side, we have logged in with the user Hadoop, right? We have logged in with the user Hadoop. So corresponding to that, in Hadoop, we also have a Hadoop folder, and that is empty. So since that is empty, so if you run this, or if you don't give any target path, it will give you the same result. Let me, for example, let me put this file in Hadoop, user Hadoop folder. I'm putting this file in the user Hadoop folder just to show you guys. And ideally now if I run this, it should show me that file, right? It's showing me that file. But if I don't even give this, even if I don't give this, it will show me that file. See. So by default, if you don't give any path here, no, who was asking this? Yeah, Shivali. So if you don't give any path here and you just run this much command, it automatically points to default user. So for all of you guys, this will be Cloudera. Because if you guys look here, in your case, it will be the user Cloudera. Correct?
Yes, sir.
For me, it will not work. It's saying, hey, there is no directory with the Cloudera because I'm not using Cloudera. I'm using Amazon Hadoop. Okay, we are almost 1 hour over the time, guys. Any question before I end? Please study. I hope you know now good things. What is Hadoop? What is MapReduce? What is HDFS? What is block reports, name node, data node? What is difference between a Linux command and a Hadoop command? How a data node is split into two parts. Data node has a Linux storage, separate Hadoop storage. Okay. So if a data node contains a total of 10 terabytes of space, almost 9 terabytes is given to Hadoop. 1 terabyte is for local Linux. Sometimes you need to do some local operations also. Consider it same as when you are starting your virtual machine. I am saying you have even 8 GB RAM. I'm saying give only 7 GB RAM to Hadoop. Remaining you keep it for your local operations, right? So that local operation is like a local file system. Because your local system also needs some memory, some storage, some CPU. So if I am making this machine, this entire machine as a Hadoop machine, it is same as you guys have made your laptop as Hadoop. Currently, your laptop is also behaving as a Hadoop machine, right? But I am not asking you to give everything to it. So that's the same thing here. If this is my data node, I am not giving everything to it. I am keeping something for local operations also. I hope that is making sense. Guys, any questions? Any feedback? Am I going fast, slow, good, bad? Are you guys fine with this pace? You want me to slow down anything? Okay.
Till now it's fine, sir.
Okay. You can send me an individual feedback also on the WhatsApp or Telegram. I will be happy to have it. Don't worry. Okay. I appreciate the feedbacks that help me to rectify my course corrections. Okay. So thanks, guys. We'll connect tomorrow and deep dive into this. And any
Thank you, sir.
feedback, do ping me on Telegram.
Okay,
Don't
sir.
think. Huh? Okay, thanks. Take care.
Thanks.
Thank you, sir.
Did you guys get the recordings?
No, sir.
Okay, I shared it already to Damini. I'll call her. Okay. Okay, guys, take care.